Hello everybody, welcome back to IZD DWF repair videos. I have on the bench Commodore PET 2001 in a rather battered state, but it's complete, and it would be fun to repair, but also I guess a bit long process. So let's see what we find inside. Okay, the outside has the usual rust cracks, but that will be later a later job after I repair the electronics. And also rust here. First thing we notice is that there's a broken fuse holder with the missing fuse, so I will need to replace this one. I have to find something similar. He does a kind of modification here. It seems like a key switch or something. I don't know. I will see when I open it. PCB is the 32008, the first revision of the 2001, with 6550 ROMs and 6540 ROMs, and looks complete, but also very dusty and dirt. Transformer is showing quite a lot of rust also. This is the modification. It appears to be interrupting the ground retard, so I will remove this one and also repair these jointed wires. I don't know why they did interrupt them in the first place, but looks like a lot of work. Let's see. Okay, looks like probably repair first the motherboard. This is how it appears after dusting off it. It is quite in a sorry state. Pins are starting to rust, but unless I want to remove all of them and replace or clean, I will first try to see what happens. The connectors need really to be tinned again, so I will do that. Remove the oxide and apply new tin, so we'll see how to do it. Components are from 1978, but there are some 1977 components like this 6520 and some other logic from 1977. The CPU was replaced somewhere in 1981 or something, because this is a Rockwell 6502 from second week of 1981. ROMs are basic 2. This is the basic 2 upgrade. The other ROMs are common to the basic 1, so it was upgraded or sold directly with a basic 2 option. This ROM is from 1978 too. So let's check the diodes with a multimeter, and then I will use my 2001N power supply and monitor and see what it looks like. I replaced this little heatsink which was missing. This is the one original, and this one was missing, so I found something similar and just replaced, but it doesn't matter too much anyway, but it was good to have it. So let's see what happens. Okay, to clean the contacts, we'll try to use this product, which is well, sold in Italy, but you can find similar products probably in your country. This kind of liquid cream to remove dirt and oxide from metals, and works with copper objects, well, any metal actually I've tried. So apply just a little drop, rub out everything, and repeat until the contact will be clean enough. This is the bottom side. This is result after cleaning, and this has to be yet cleaned. This one too, which is the internal tape connector, and finally this one, which is the memory expansion bus. Even if I don't plan to use it, but it's not good to leave oxide between contacts. Could be shorting signals and so on, so it's worth cleaning. Next step is checking diodes, which I did with the multimeter. And remove any socket chip and clean the inside of the socket. We never know. The sockets are very low quality as always. Funny things that I noticed on this 32008, on actually any board that has this serial, this part number that I happened to repair, has the same problem. You notice this socket, this is the CPU socket. It doesn't have any clear notch, but this side is a little bit more recessed than this one, which is almost flat with the pins. So I assume this is the pin 1 side, and for the CPU socket this is the case. But if I remove the 6522 and the 6520, these two ones, they are upside down. I'll show you. 6520 on the end of the port, which has a notch down, and this is its socket, which has the recessed part on the other side of the actually pin 1. And this is the socket of the other 6520, the keyboard one, which is mounted on this board with the notch up, and it corresponds with the recessed part of the socket. So I found also the orientation of the sockets on the RAM columns is quite random, so never trust socket notch on 2001 Commodore 2001 PCB. Just double check before inserting chips. Now the next check, as you may know, the power regulation of the 2001 is composed of 4 different 7805 regulators. They are the 1 ampere version with very large heatsink, and each of the 7805 powers a different set of chips. And if we measure the resistance with nothing, no power input connected between the ground, which are these 2 pins, and each of the 5 volts pin of the 7805, which should find, like in this case, not much less than 200 ohms. So this is the first, this is the second, this is the third, and this is the last one, which shows 75 ohms, which to me seems a bit too low. Now this one, if we go on the schematic, or if we follow the tracks on the other side of the PCB, mostly powers the first 3 rows of RAM and the first 3 ROMs from the bottom. So let's remove these 3 rows and see if there is any shorted IC. Now, with all the components removed, I didn't find any other component that should be powered by this first regulator. We have the 226-27 ohm. Don't know, maybe capacitor or something like that. I guess I will attempt to power the board on, measure the voltage outputs on all regulators. The first power on, no smoke, no really burning chip or capacitors. Voltages on all the regulators quite okay. 3 and last one. Of course, the heatsink is not getting hot like the other one, because it's still missing a good part of RAM and ROM. So this is almost unloaded, but output look good. Well, anyway, let's connect to the oscilloscope and maybe a monitor. This is the input clock to the 6502, which is good. Yeah, pins are not very clean, but okay, this is one of the phase output clock, and it's good too. This is the other phase, but okay, the pin is not very clean, but well, it's okay anyway. Just check it before. So I think the next step would be checking with my test setup every RAM chip and every ROM chip, then connect the monitor and see what we get. Finished the test of the 6550. The top row chips that passed all the tests without problems. Unfortunately, some chips don't pass all the tests, but that is to be expected with the 6550 RAMs. Unfortunately, they were not perfectly made probably, but these chips have various faults. I tried to mark them with some symbols to remember what they have. Some of them are just too slow to respond or to accept inputs. I don't know why, but I've found this behavior other times on the 6550. and I will try to use them anyway, see if they can work reliable in the 2001 motherboard. Some of them don't go in the high impedance data bus state when some of the input the chip select inputs are disabling the chip, but this should not be a problem to use these chips in the video RAM sockets, and I will explain why looking at the schematic. Okay, here's a 6550 on regular main memory of Commodore PET 2001. As you can see, the various chip select are hooked to different addresses and select signals. Most of them actually some of them are just tied to ground or +5 in this example, but at least 3 of the 4 selects are used to actually to actual signals to select the different segments of RAM to the various chips. So basically, if we have non-working select line, the only option is either the chip select 4 is broken and we can put that RAM in a J8 or I8 position, or for J4 and I4. That would be the only place where the chip select 4 is not used, or in other locations, any other location as the pin 21, which is the chip select 1, and is not used because it's tied to +5 in any other position but 8 and 4. Of course, the clock, the F2 phase 2 clock is used in every location of the main RAM. But if we look at the video RAM, that's a different story. Okay, here is the 6550, one of them in the UC3 or UC4, used in the video RAM, always PET 2001. As you can see, all the select are tied, what the active high select are tied to +5, of course the negative, the active low selects are tied to ground. So these RAMs are always selected, of course, when the phase 2 clock is high. This is the phase 2 clock input, which is yet another active high select actually, but it's the only selection line that is used on the video RAM position. So since I've discovered that 2 of the tested 6550 have one broken select, or yes, one broken select, either I don't know exactly, I don't remember what of the actual select is broken on what the 26450, but I can put the broken select chips in the video RAM position because they are not used. Of course, the select is broken in the way that even when the line is not selected and all the other lines are selected, the RAM is globally selected. So it doesn't, it works like the select is internally always enabled, and this is quite a common failure on some of the 6550, and this kind of failure does not prevent the RAM to be used in the video RAM sockets. So that's what I do. Okay, of course this is a bit of cheating, because I'm using my RAM-ROM replacement in this moment, and both ROM and RAMs have been provided by the daughterboard via this EEPROM from the ROM image. But the two video RAMs are the Select Impaired 6550, and they appear to work fine. And I will demonstrate the other broken 6550 in the video RAM position briefly, to show what you would expect on a video with a non-working 6550. I tried to select the external RAM, even if I populated all the rows at the last three with tested good 6550. I have not a successful boot with using this motherboard RAM. It means that there must be some logic problem around that prevents the main RAM to work, and we will find out also this issue later. Here's what happens when one of the video RAM, this one for example, has a stuck bit at 0. Character look no good, and all numbers look like 0. Most letters look like the @ sign, and so on. This is one example. Here is what happens when there are stuck bit at 1. So characters look like the next in the PET ASCII table. So the 20, this case looks like 22 or 25, I don't remember, but there are some bits stuck at 1. Finally, here's what happens with the 6550 that appeared to be too slow on my test setup. You see, as the screen shows copy of the cursor, probably 1, 2, 3 every four addresses, and some character also change during the time when probably when the RAM gets hot or something. But anyway, this cannot be used on even on the video RAM position. So enough with the faulty 6550. Now let's try to debug the main RAM problem. Okay, now I have enabled the test section of this ROM set that I installed. Enabled almost all ROM access, but the 8K segment which contains the test to the mainboard ROMs, all RAM enabled to the mainboard RAM. And this test tells that the row 1, 2 and 3 are bad. This is RAM. The row 4 and 5 are okay, and of course 6, 7 and 8 are bad, but 6, 7 and 8 are missing. These are all tested as good, and I also tried to swap the row 4 with row 1, and that didn't change anything. And for the ROMs, it says the only good should be H6. H6 is this one. I removed H7 because H7 is mapped anyway on the daughterboard ROM, so it wouldn't test it. But this test can test the H7 ROM in the H6 position. So next I will put this ROM in the H6 position and see if it tests us okay. The H7 ROM in H6 position, and it tells it is the 018, which is right, and it's okay. All the other also shown as empty, but I hope there is another problem like in the RAM addressing. So let's look on the schematic. What is a common signal between rows 1, 2 and 3 that is not present in rows 4 and 5. Just for testing, I also put the 19 ROM, which leaves usually in H1, in the H6 position, which seems the only that is really accessible. It sees something, and this is the checksum, but it doesn't recognize either the 14 or 18, which are the ROMs that you expect in H6. So probably also the ROM are okay, but there are some addressing problems that prevents most of the sockets to be accessed correctly. Okay, the problem is a lot simpler than addressing or data bus or something. This regulator is put in 0 volt output, but its input, which is the spin, has a good 9 volts, 9.5 or 9.6, and either is shutting down for high temperature but is cold at the moment, or it is broken. If it was working as short circuit, it should be very hot. So this, I'll change this 7805. I replaced that 7805, and now it has a good output. And the situation is this one. The first 3 rows of RAM are okay, reported okay, but the 4th, which was okay before, is now bad, and the 5th, which was okay, is still okay. Now it may be possible that one of the RAMs in row 4 failed, but so I will swap the 4th and the 5th row RAMs just in case. But on the wrong side now we have ever changing checksums. I'm sure H6 was okay before. Yeah, that was the one that was okay, and the other one are just showing changing results. So I think there may be something else bad, so let's look around. Swapping the 2 rows moved the error from row 4 to row 5, so I hope only one 6550 failed, because I have only one good spare. So let's try. Okay, now using a spare chip gives all the rows was okay, and the ROMs are still looking bad. There must be some chip powered by the previously dead 7805 that is the problem. So I'm gonna look for that. If you remember at the beginning of the video, I found that the resistance on the line powered by that failed 7805 was too low, so there must be some glue logic that is failed and is powered by that 7805 that failed for the too high dissipation. In fact, it's very hot. It's the hottest way the hottest. So yes, let me power it down for the moment. Okay, one bad news. Almost all the ROMs look okay. Well, that's a good news actually. And the bad news is this one was the problem. This is the 6540 016, and it is the last chip powered by this regulator, which now doesn't seem so hot, or not much hotter than the other. So yeah, that was the problem. And so the first 7805 powers the first 3 rows of the RAM, and the first 4 ROMs going from 1, 2, 3 and 4, and the last one was the one that made the whole bus flicker or something, because, well, I will test this one with my chip tester for the 6540, and anyway I think this is the problem. So it's bad. Here's the PET working almost by its own. You see, almost 4 kilobytes of free RAM. That's because we have the first kilobyte is used by the system. So 1, 2, 3 and 4 kilobytes are free for basic. And I'm only using the daughterboard ROM to replace this couple of ROMs. The first H 1, 2, 3, 4, 5, 6, 7, H7 and H4. All the other are addressed on the motherboard. So the with this setup of my expansion, RAM replacement, and on a 2001 I can select ROM only in couple. So this one and this one, this one and this one, this one and this one, and so in this moment I know that this one is good because it was tested in this place. So the only failed ROM in this 2001, it was the 6540 016, and okay, that's sad, but we can now test the machine and see if all the rest is working. So I think I'm splitting up this 2001 repair in more than one video. So the end of the first part is that I will populate this RAM-ROM replacement board, which is one of my first revision batch that has not the possibility to select what banks of ROM and enabled on the motherboard and what other addresses are provided by the onboard EEPROM, but can only select between internal and external, and select 2 different internal images, which will be enough for this PET, and of course can select external or internal RAM. I would put an EEPROM with a complete basic 2 set, like this original set, until maybe I find a 016 replacement, and it will have as the second image basic 4, which is the last basic available for the 2001 I mean, and it will have some ROM expansions that can live inside the daughterboard ROM. And so I will will have this machine with 5 kilobytes or 32 provided by this board, and the original basic 2 was provided by the board until I found a replacement, and basic 4 if I want to enable basic 4 for this machine to use disks and anything else more modern. And so the rest of the machine, keyboard, tape and so on, will be covered by other videos. So stay tuned and thanks for watching.